What is SHM? In this video, I think so you have been all confused in simple harmonic motion. So in this video, we will be talking about simple harmonic motion and what is simple harmonic motion. But before going into this concept, I want you all to understand, to clear your concept for velocity and for acceleration. And why it is important, because the concept of simple harmonic motion is having a concept of acceleration, and without acceleration you cannot understand simple harmonic motion. So if you like my video, please subscribe to my channel and press the bell icon and like my video for more informative videos for physics and mathematics. Let's get straight into this topic. We are going to study SHM, that is simple harmonic motion. And I already told you that before going into this concept, I want you to please clear your concept for velocity, clear your concept for acceleration. Without all these concepts, you cannot understand a single word I have told in here. This is a pendulum, and for SHM, this is a very great example, a pendulum. Pendulum is a very great example for SHM. I have been coloring it. Many students can easily understand the concept of acceleration through this pendulum. Alright, now for example, this pendulum is at point O. So I have just given a name this pendulum as point O. Alright, now what I'm going to do, this pendulum is at rest. When a body is at rest, it means its velocity is 0. So the pendulum is having a velocity 0 because it is at rest. And when a pendulum is at rest, then the pendulum is said to be in mean position. So this is a mean position for pendulum. Pendulum is at rest, it means it at mean position, or you can use another word called equilibrium position. Equilibrium means a body which is at a state of rest, and mean position here also refers to a body which is at rest. So pendulum is at rest. So for example, if I displace this pendulum towards here, so I have, for example, picked the pendulum and displaced it through some displacement. For example, this is the maximum displacement I have given to the pendulum. So this is the maximum. For example, I have displaced the pendulum by 4 centimeter. So that my displacement will be 4 centimeter. If I displace the pendulum by 5 centimeter, then my displacement is 5 centimeter. Alright, for example, now let's join the rod here. So I have displaced the pendulum by 4 centimeter, and now I have named the point as point A. So I have displaced the pendulum, this is the bob, from point O to point A, and this is the displacement which I have given to the bob. Now as you can see, I've been holding this bob, and when I'm holding it is at rest, it means its initial velocity is 0, or in like this, v equals to 0. So v equals to 0, that will be very good. If I leave this bob, it will go straight towards mean position, and when it moves toward mean position, when it reaches to mean position, its final velocity will be either 1 meters per second. It will be either 0.4 meters per second, because as you know that when a bob is displaced from origin to point A, it will not, and when I release the bob, it will not stop here, it will move towards point A, and the reason is that the gravity will pull the bob towards point A, and when it reaches to point A, it will not stop. It has some velocity, and when a body is having some velocity, it will never stop. It will continue its motion like this and will reach at here. So the pendulum now reached to point B. First, when I displaced the pendulum from O to A, and when I released it, it moves to O, and due to inertia, because due to it is having a velocity, it will not stop here, it will move towards point B, and when it moves towards point B, again its velocity becomes 0, and due to gravity, again the bob will move towards O, and when it comes towards O, its velocity again will be some, maybe 1, maybe 0.4, maybe 0.6, any kind of velocity, but it is, the bob will have velocity, and due to it is having velocity, it will again not stop, and it will again continue its motion towards A, and like this it will vibrate, it will move periodically. Now what is periodically? Basically the motion in which a body, an object, repeats its motion. You can see that is repeating its motion continuously, and that is why we call this motion as periodic motion. Now we have learned the definition of periodic motion, that an object which continuously repeats its motion after a regular interval of time, then the motion is said to be periodic, and this is repeating its motion. For example, now let's head towards simple harmonic motion. A simple harmonic motion is a periodic motion. Now first point is very clear, very easy peasy, that simple harmonic motion is a periodic motion. So not every motion is a simple harmonic. There are three types of motions. The number one is number two is rotatory, circular or angular, and the number three is periodic motion. So not every motion is a simple harmonic motion, only the periodic motion is called simple harmonic motion. Now what is simple harmonic motion? Simple harmonic motion is a periodic motion in which what happens, let's see. For example, I have displaced the bob from O to A, and when I displaced it towards A, its initial velocity was 0. For example, when I release the bob, it comes towards mean position after 1 second. For example, let's take after 1 second, and after 1 second, for example, its final velocity at the bob will be 1 meter per second. It will not be 1, it will be 2, it will be 0.4, it will be 0.6 meter per second, doesn't matter, you can take any of those. As you have heard, its velocity is increased. First of all, before the second it was 0, and after the second it was 1. It is 1. Now let's calculate the acceleration. So acceleration is basically final minus initial divided by time. The time is 1. Now 1 minus 1 is 0, and 1 divided by 1 equals 1. So this is its acceleration. The acceleration is 1 meter per second, and there you can see it's positive. The acceleration is positive. The positive sign indicates that the direction of acceleration is same as the motion. Now what I am talking about? Basically it's all the concept of acceleration, but if somebody didn't know, I'm just gonna give him a hint and continue to move forward. For example, this is a car. There is a car, this is a car, and it is moving with 2 meters per second. After 1 second, for example, its velocity increases by 2 meters, and when it increases, it's become 4 meters per second. After 1 second, its velocity becomes 6 meters per second. After 1 second, its velocity becomes 8 meters per second. So you can see in every second its velocity is increasing. So when its velocity increasing, then acceleration must be positive, and the direction of due to acceleration is a vector quantity, then it represents that the direction of acceleration will be the direction of motion. What did it represent? You can see the car is moving towards right. As acceleration is positive, then the direction of acceleration will be the same as the motion. That is, this is the direction of motion, and this is the direction of acceleration. But if I say its velocity is decreasing each second, for example like this, You can see in every second its velocity is increasing. For example, 8, after a second it becomes 6, after a second it becomes 4, after a second it becomes 2, and each second the velocity is decreasing. So when velocity is decreasing, then acceleration is never positive, it is always negative. And the negative sign shows that the acceleration direction of acceleration will be opposite to the direction of motion. What did I say? For example, the direction of motion is at right, and when the direction of motion is at right, then the direction of acceleration will be at left. You can see it is at right, now the direction of acceleration will be at left. So this is the concept of a car that I am telling you about the acceleration. Now we all have to do is patch this idea onto this. When it was at A, it was 0, but when it comes to origin, its final velocity becomes 1 meters per second. So if I say its velocity increase, how much its velocity increase from 0 to 1 in just 1 second. So let's find acceleration. Final velocity is 1, initial velocity is 0, upon time period is 1, 1 minus 0 is 1, and when 1 divided by 1 equals to 1, this is its acceleration, and this is positive, which indicates that the direction of acceleration is same as the direction of motion. So where is the bob moving towards? It is moving towards mean position, and due to acceleration is positive, so the direction of acceleration will be also towards mean position. So here you can see the acceleration is directed towards mean position, or you can say at point O. So the point O is same as mean position. So the first concept has been clear, that acceleration is always directed towards mean position. So let's take another concept. At O, its initial velocity, let's suppose, is 1. Now at O, it is not stopping. Basically we are continuing the motion. I have released the bob at point O, at point A, and when it comes here, its final velocity becomes 1. But right now we are considering the final velocity as initial velocity, and as initial velocity it is 1. Due to having a velocity, it will never stop here, and it will continue its motion towards B, and when it reaches towards B, its final velocity u becomes 0. For example, take it that's after 1 second its velocity becomes u. You can see here its velocity was first 1, and then finally it becomes 0, so its velocity decreases. So let's put on a formula. Acceleration equals final is 0 minus initial is 1 upon time is 1. 0 minus 1 equals to minus 1, and when minus 1 divided by 1 equals to minus 1 meters per second square. This is the acceleration. You can see here minus sign, which indicates that acceleration, the velocity of the body is decreasing each second. Each second. So you can see here, as I told you in previous in a few minutes ago, then when the acceleration is negative, then its direction will be opposite to the direction of motion. If the object is moving towards left, the direction of acceleration will be right. If the direction of motion is at right, then the direction of acceleration will be at left. So here you can see the object is moving from O to B. As the object is moving towards B, the acceleration being negative will have an opposite direction, like towards O. So that indicates in both situations you can see the acceleration is directed towards O, where O, the mean position. So let's take another example. When it is at B, let's consider this final velocity as initial, and when it comes towards O, let's consider this final initial velocity as final. After 1 second, it reaches at O, and its velocity become 1. So let's see how much velocity. You can see its initial is 0, final is 1, so its velocity increases. Due to its velocity increasing, the acceleration will be positive, and as you can see, the bob is moving towards O, so the direction of acceleration will also be towards O, because the acceleration is positive. Still in this situation, the acceleration is directed towards O. So the first point of simple harmonic motion is that in a periodic motion, if the acceleration is directed towards mean position, I have indicated by O. So the first point we have understood. Now the second point, what I'm going to tell you about, I have displaced the pendulum at 4 centimeter, and when I displace the pendulum to 4 centimeter, its acceleration is 1 meters per second square, as we have seen, as we have calculated. For example, I will rather displacing 4 centimeter, I displace it by 10 centimeter, this whole length as 10 centimeter. Alright, so I have displaced this pendulum by 10 centimeter. Now what will happen? I have displaced the pendulum up till 10 centimeter. Now what will happen? Its initial velocity is 0. After 1 second, it will reach at point O. What will happen? When it reaches to point O, instead its final velocity is 1. No, its final velocity will be 2 meters per second. What happens? Basically, when you increase the displacement, then when it comes to O, its final velocity will be greater. You can see here, in the first condition, when I was displacing the bob up till 4 centimeter, its final velocity becomes 1. But when I displace the bob up till 10 centimeter, its final velocity becomes 2. What happens? Its acceleration increases. First of all, its acceleration was 1 meters per second square, then now its acceleration becomes 2 meters per second square. How? Basically, when you increase the displacement, its acceleration increases. When you decrease the displacement, its acceleration decreases. So acceleration is directly proportional to displacement. As you increases the displacement, the acceleration will increase. As you decreases the displacement, the acceleration will decrease. So acceleration is directly proportional to displacement, and displacement is always indicated by negative sign. There's no such logic behind it, just you have to assume it. Now the 2 points that you have understood clearly, and that is the concept of simple harmonic motion. So here you can see I have written 2 things that I have explained you. Number 1, acceleration is directly proportional to the displacement of the vibratory object, and acceleration is always directed towards mean position. So this is the definition of simple harmonic motion. So simple, so easy, it will take a lot of time to understand, but once you understand, it's so easy. Simple harmonic motion is a periodic motion in which acceleration is directly proportional to the displacement and acceleration is directed towards mean position. This is called simple harmonic motion. If you like my video, please subscribe to my channel right now and press the bell icon for more notification, and if something that I didn't clearly define you, so please be sure to comment on my channel. Take care and bye.